G'day, this is just a series of videos on angle properties of a circle. I'm doing this for a Year 11 specialist maths class, so yeah, if this relates to you, then I hope it's helpful. Just a couple of definitions before we sort of get underway. Things like, you might know this already, but I just want to clarify chord. Imagine if I've got a line here that cuts through this circle at 2 points, and it's a straight line, and we're going to say one end is C and the other end is D. The chord is the part where it cuts the two circles. So in between those 2 points there, if that point is A and that point is B, the yellow, that's what the chord is. The secant is actually the entire line from C all the way over to D. And this final word that will come up a bit is subtend, or the angle subtends A and B. So if we have this other point down here called P, and we draw a line between AP and BP, then what we can say is that this angle in here is the angle subtended by AB at the point P. Okay, so hopefully that can just help clarify some of the definition issues that we've got. Okay, there's a couple of theories or theorems that I want to go through with you, and here's the first one. I'm going to explore this angle in here and this angle in here and see how they are similar and how they are different. What I'm going to do is I'm going to draw this little diagram here, so A, P, B, and with the center at O. I do know that the radius is the same everywhere, so I know that those two are the same. And then if I skip over to this diagram over here, which is the same thing just without the circle, I know that those two are the same, and I also know that this line in here is the same as well, okay, because it's just the radius of a circle. Now I can see that these triangles are actually isosceles triangles. They may not be the same isosceles triangle, as in this line can be different to this line, but at least I know that those three sides are the same. Okay, and then what I'm going to do is I'm just going to explore some angles. I'm going to call this angle A, and if that angle is A, then this angle also has to be A as well, because it's an isosceles triangle. Similarly, B and B, hopefully you can see that squeezed in. And now I guess I just want to look at this angle over here. This one I'm going to call that X. Okay. I know these two angles here because I know that they are 180 minus 2B. And this one will be 180 minus 2A. Sorry, it's a little bit squeezy, but hopefully you can see where I'm going with that. Yep, because three angles in a triangle all add up to 180, so that one's going to be 180 minus those two angles there, which is minus 2A. So what do I know about X plus 180 minus 2A plus 180 minus 2B? Well, if you have a look here, that is a complete circle around there, which means that has to add up to 360. I can see 180 on this side and 180 on this side. Those two add up to 360, so those two will disappear. The same with that will disappear, or when I say disappear, it will be replaced by 0. So I'll have X minus 2A minus 2B equals 0. So I get X equals 2A plus 2B. I'm going to write that as X equals 2A plus B. Okay, so now I'm coming back to what I actually want to originally work out, and that was this angle here compared to this angle here. This angle here is going to be A plus B, just based on what I had before. This angle up here is going to be 2A plus B. So I guess that sort of leaves us with a theory, or a theorem, that the angle at the center of the circle here is twice the angle at the circumference subtended by the same arc. Okay, you can see from the diagram there that if that's X, this one over here is 2X. Thanks very much. I hope that was helpful. I'll show you the next one in the next video.